All right, good morning. Since I'm not going to be in class today, I thought I would put together a quick little video lesson for you. We're going to be learning how to write formulas for ionic compounds. In order to do this, you'll definitely want your periodic table, the one that has this ion chart on the back of it. We'll be using this as a reference. Also, as I'm going through these examples, I would make sure to have a notebook out. That way you can follow along in your notebook and write down these examples and how to write the formula for ionic compounds. You kind of see how I have this laid out up here. I'm going to start with the name of the compound, and we're going to work our way down to the formula of the compound. So I'm going to just run through several examples, and hopefully by the time we're done with this, you'll have caught on to the technique and be able to do these on your own. You will have a worksheet that has plenty of practice on it, and so we'll start with this one. I have the formula, or I have the compound aluminum chloride. The first thing that I always like to do is to write down what the ions in this compound are. So we have the aluminum ion. And when we write ions, we write their charge in the superscript. And even though it seems a little backwards, we write the number followed by the sign. So the aluminum ion is a +3 charge. And I knew that from looking at my ion chart. You should be able to find aluminum in the column under where it says cations. And then chloride, again, by looking at the ion chart, you can see the charge of chloride is -1. I always like to make note of what those ion charges are, and the whole thing with writing the formulas for ionic compounds is the compound has to be neutral. And so if you have an ion with a +3 charge and an ion with a -1 charge, when you put those together, you don't have a neutral compound. And so we need to multiply the -1 charge by 3 in order to make it neutral. So you have +3 and 3 -1s. And if you have 3 -1s, then you end up with a neutral compound, right? So one of the things about ionic compounds is they're always neutral. By multiplying the number of chlorides by 3, we end up with charges that balance. And so the final formula reflects the number of ions for each substance in the compound. So you have 1 aluminum ion and you have 3 of the chloride ions. Also notice when I write the final formula, I only include how many. I don't include those charges in the superscript. I just put how many there are in the subscript. So the final formula for this compound is AlCl3. We'll do another example. This example I'm going to do magnesium nitride. And here, when you are using this ion chart, pay close attention to the names of the ions. There's several that sound like this one, nitride. There's also one called nitrate. There's one called nitrite. And so you got to really pay attention to which ion is in this compound. So magnesium, you should be able to find that one. Magnesium is a 2+, and nitride is N, and it's 3-. And so the ion charges, this is a +2 ion, this is a -3 ion. And so, as we mentioned before, we need to make sure that this ends up being neutral. If you pair something that's +2 with something that's -3, it's not going to be neutral. And so you've got to find the multipliers to make it neutral. If we multiply these by 2 and 3, respectively, then you end up with, if you do 3 times +2, you end up with +6. And if you do 2 times -3, you end up with -6. And so that ends up being neutral. In other words, we need 3 of the ions with a +2 charge, and you need 2 of the ions with a -3 charge in order to make a neutral compound. Telling us the final formula for this compound is Mg3N2. And again, that reflects the number of ions for each one in this compound. Again, we leave the charges off when we write the final formula. We'll do a couple more examples here. This one I'm going to try. Calcium hydroxide. And again, you want your ion chart handy so that you can see, okay, calcium, if I find that on here, calcium is +2. Hydroxide, this one's a little different because this is what we call a polyatomic ion. It's actually 2 atoms that together make an ion that has a -1 charge. And so we have calcium, we have hydroxide, and just by looking at the ion charges, it should be pretty easy to figure out how to balance this thing. I need 1 of the ions that has a +2 charge, and I need 2 of the ions that has a -1 charge in order to make it neutral. When we go to write the final formula, since this one was a polyatomic, I'm going to use parentheses to show that those atoms are grouped together as an ion. And so I write the final formula. I need 2 of these hydroxides. So I put parentheses around the OH part, that's the hydroxide part, and then I write the subscript to show that I have 2 of those. So the final formula for calcium hydroxide is CaOH, parentheses around it, 2. And I've got one more example that I'd like to go through. And this last one, I'm going to write the formula for a compound, iron 2 bromide. And so this time you see in the name, there's this Roman numeral. And if you look at your ion chart, what you'll end up seeing is that you'll see there's more than one type of iron. There's iron that has a +2 charge. There's also iron that has a +3 charge. This iron, the Roman numeral, indicates the charge. And so this ends up being the iron that has a +2 charge. Right? If it was iron that has a +3 charge, we'd call it iron 3. And then bromide is -1. And so again, once you see what those charges are, it should be pretty straightforward to determine what the formula is. This is, we need 1 of the +2s, and we need 2 of the -1s. And so the formula for iron 2 bromide is FeBr2. And again, we need 2 of the ion with a -1 charge. Don't get confused into thinking that this Roman numeral tells you how many ions. It doesn't. The Roman numeral simply tells you what the charge of that ion is. And then you can figure out what the formula is based on those charges. Good luck with this. And again, if you have questions, you can always come and find me before or after school up in room E370. Or another good way to get your questions answered is to look for some help from your classmates, and or YouTube is another good resource. You can always find videos out there on how to do these formulas for ionic compounds.